Dear civil engineering students and viewers, today we will study about simplex method, which is applied to the construction planning management, especially the construction activities. How to utilize the simplex method in construction activities, that would be discussed in today's lecture. So simplex method in construction activities. So let us take this problem. Here the construction company is working on two projects. First one is project A and second one is project B. It is working in project A. Project A is the residential building and commercial complex is the project B. The company has limited resources, that is 120 hours of skilled labor per week. So here the constraints are per week there are 120 hours only. Okay, this is a constraint. So you can utilize only 120 hours for both the projects, and you have limited construction materials. That means you have only 80 units of materials per week. These are the constraints. Okay, then the point is 120 hours of skilled labor is available and 8 units of materials are available. The project A requires 4 hours of skilled labor. So this is for project A, and it requires 2 units of material. So 2 units of material are required. So that is given about project A. Then you can see that the profit is $300 per unit. So we can write down here $300 per unit. Okay. Then project B requires 3 hours of skilled labor. So the project is B is requiring 3 hours. What is project B? Project B is nothing but it is the commercial complex. And finally, here you can find project B has 4 units of material per unit of work. So it requires 4 units. Okay. Project B. Now the point is, it yields a profit of $400 per week. So here it yields $400. Now this is the given data from the problem. The company wants to determine how many units of each project to undertake weekly to maximize the profit. That means they want how many units should be undertaken so as to maximize the profit of the company. So you can use simplex method and find the solution. So let's use the simplex method. Now you look at this, that these terms are related to the project A and these terms are related to project B. Okay, and you have the constraint 120 hours could be utilized per week and 80 units have to be spent for 1 week. Now let us frame the equations. So while framing the equations, we have to analyze the project A and project B. So this project A plus project B, you can find out that it should be less than or equal to 120 hours. Then regarding units, if you combine project A and project B, it should be less than or equal to 80. Then the profit is between project A and project B. that should be maximized. So if you take this one as Z, Z is the profit. So you have to maximize the profit. So be clear with the concepts that the project A and project B, they are happening simultaneously. Then you are owning a company. According to the constraint, you can only have 120 hours spent per week, and you can use only 80 units per week. These are the constraints. Okay. Now, based upon this, you have to find out, maximize the profit. So this is the profit. So 300 per unit, $300, and here for project B, $400 per unit. So we will proceed further. So here you can see that X is the number of units of project A and Y is the number of units of project B. So go back here. Here you can add X. Here you can add Y. Here you can add X. Here you can add Y. Similarly, here X and here Y. So first of all, you have to understand the problem and then you have to formulate. Once the formulation is done, the 90% of the problem is done. Rest is nothing but the manipulating the values by means of operations of rows. So you have to understand this problem, and we are going to apply the simplex method to maximize the profit. So this is a maximization problem, and most of the students study this in operations research also. Now finally the equations are here. 4x plus 3y less than or equal to 120, 2x plus 4y less than or equal to 80. This is equation 1, this is equation 1, this is 2. This is maximizing the profit. Okay, so whatever I told you that we have formulated. Then proceeding further, here since you can see that this carries less than or equal to, and this is maximization problem, and so we can use slack variables. So 4x plus 3y plus s1 equal to 120, 2x plus 4y plus s2 equal to 80, and here you can rewrite the equation like this: 4x plus 3y plus s1 plus 0 into s2 is equal to 120. Then you can write 2x plus 4y plus 0 s1 plus s2 equal to 80. I hope you have understood and got the concept. That means S1 is the unused labor hours. So unused labor hour means sometimes the government means is to stop the construction project because of the pollution and all. So at that time, for example, per day if you are working for 12 hours, that 12 hours means unused labor hour. And unused material units in the sense, suppose you order ready mix concrete from a plant and the truck has reached your construction unit, but due to some orders you want to stop the construction, and immediately you stop the construction so that the concrete 4 meter cube or 6 meter cube in the truck gets unused. So that is said to be unused material unit. So similarly, I told you about unused labor hours also. Now this is the equation 1 and this is equation 2, and you are maximizing the profit. While maximizing the profit, you had 0 s1, 0 s2. Then finally you are going to write all these things in this format. So here you write x, y, s1, s2, RHS. Then here you put basic. Okay, these are the basic variables. And s1 and s2 you write here. So 4x plus 3y, 1 s1 plus 0 s2 equal to 120. Then s2, 2x plus 4y, 0 s1 plus s2 equal to 80. Then you have z equal to minus 300 x, z minus 300x minus 400y, and these values are 0. So first of all, this is the format of initial simplex tableau. Now you have to prepare this table to solve the problem. Now I will explain you how to solve. So the very first step is you observe this last row. In this row, minus 400 is the most negative value. So you choose this column. Then you choose this RHS. Here you have to find out, or you have to make ratio test. So ratio test, you divide this value 120 by this column, this element you divide by 3. So this and this are connected. Similarly, you divide this 80 by 4. So here you have 80 by 4. Now this is equal to 40 and this is equal to 20. So how did you find that? First you find the most negative, then you draw a line here, then you find out the ratio. So 120 by 3 and 80 by 4. Okay. Now this is what you have. Then from this, what you have to do is, this is the minimal value. So from here, if you draw a line, they meet at this point. This element is called pivot element. You understand? Now here, so whatever I told you, this is the most negative, and here this is the minimum. So they meet at this point. This element is called pivot element. Then this is row 1, row 2, row 3. Okay. Now what we are going to do is, this pivot element should be converted to 1, and this, the element of this row should be converted to 0, and the element of this row should be converted to 0. So how you are going to do that? Whatever you do, you have to do throughout this row. For example, if you want to convert this 4 to 1, you will divide this 4 by 4. Similarly, you have to divide this whole row by 4. 0 by 4, 1 by 4, 80 by 4. You understand? Yeah. Now here, whatever I told you, we are executing. So new R2 equal to R2 divided by 4. So you are going to divide this by 4, divide this by 4, divide this, and divide this. So here you can see the values 0.5, 1, 0, 0.25 and 20. Now we are done with this. Next we have to make this 0. So we will operate this row R1 by this row R2. So new R1 equal to R1 minus 3 into R2. For example, if you multiply this 1 by 3 and subtract it from this one, you are getting 0. So similarly, you multiply this by 3, multiply this by 3, this element also multiplied by 3, this is also multiplied by 3. Then you are subtracting it from this row. You are subtracting from this row. You are getting 2.5, 0. That is 2. How you get 2.5? 4 minus 3 into 0.5. That is 4 minus 1.5. You get 2.5. 3 minus 3 into 1, 0. Then 1 minus 3 into 0 is 1. Then here if you multiply 3 into 0.25, that is 0.75. 0 minus 3 into 0.25 is minus 0.75. 120 minus 3 into 20, it is 60. So now this is also okay. You have made 0. Now you are going to convert this element to 0. So how can you do that? You have to take this pivot row and you multiply 1 by 400 and add with this element. So you have to multiply 0.5 by 400 and you have to add with this 300. Similarly, you multiply all the elements by 400 and then you have to add it with these elements separately. So that we will get here. Now we have got here new R3 equal to this R3 plus 400 into R2. So this is 400 into R2. This is 400 into R2. You are getting this. Okay. Now you have to understand one thing, that once you identify the pivot element, this Y has to be substituted here and this S2 has to be removed. Now you are done with this first iteration. Now what we have to do is, then finally you observe this Z here, minus 100, 100, 8000. So the most negative is, and minimum or most negative is this one. So this is the column that has to be chosen. Then again ratio test has to be done. So how will you do that? You divide this 60 by 2.5. You divide 20 by 0.5. Let's do it. Yeah, this is what we have. Most negative is 100. You draw a line here. Then you divide this 60 by 2.5. You divide this 20 by 0.5. Then you are getting 24 and 40. So this is the minimal value. Now you draw a line here. So this element is the pivot element or pivot element, whatever you call. Now you make it as 1. So how will you do that? You divide this whole row by 2.5. So that is what we do. This is the pivot element. This element is called pivot element or pivot element. This element, pivot element. So this is the pivot element. Now you convert it to 1. So how you are going to do that? You divide this R1 by 2.5. So R1 equal to new R1 equal to R1. Meantime, you take this X and bring it here, because this X is the pivot element. This 2.5 corresponds to X, which is the pivot element. So you take this X and substitute it here. Now you divide this by 2.5, 2.5, 2.5, 2.5 and 2.5. You are getting these values. You are getting these values. These are new values. You have made it 1. Then next what we have to do? We have to convert this one to 0. We have to convert this one to 0. So whatever you do, you have to take this row and operate on other rows. Now how to do that? Yeah, new R2 equal to R2 minus 0.5 into R1. Note down that here this is 0.5. To make it 0.5, you have to subtract it, subtract the 0.5. So how you can do that? 0.5 minus 0.5 into row 2 equal to R2 minus 0.5 into R1. So if you operate this on this row, you will end up with 0.5 minus 1 into 0.5, 1 minus 0, 1, then 0 minus 0.5 into 0.4 is, here you are getting minus 0.2, 0.25 minus 0.3 into 0.5. So what do you get here? You get here 0.4, and 20 minus 0.5 into 24, you are getting 8. So this operation is successfully completed. Then you are left out with this table. This is the new table. So in this table you have to make this minus 100 to 0. So how will you do that? This is the row which you have taken. So this row is taken as the row belongs to pivot element, and minus 100 you have to add plus 100. So you multiply this row by 100. So each and every element in this row should be multiplied by 100 and should be added with this row. If you do that, so what you get? R3 equal to R3 plus 100 into R1. 0, 0, 40, 70 and 10,400. Now you stop here. So because you have got what is X, X is nothing but 24. and we have to stop the iteration because finally we arrived the S1 and S2 and RH. That is the profit is obtained here. So this Z is equal to $10,400. So this is the $10,400 per week is the profit for the company. We have technically found how the company can maintain or can have the resources for project A and project B. So X equal to 24, Y equal to 8 units. So 8 units is for Y is for project B, X is for project A. So project A you have to spend 24 units, which is 3 times greater than the project B. And per week the company gets a profit of about $10,400 in dollars. If you convert it to Indian money, probably it would be nearer to 1 lakh. Now we have to substitute in the formula 4x plus 3y, and if you do that, 4 into 24 plus 3 into 8. So what do you get? 4 into 24, 96. 3 into 8 is 24, equal to 120 units. Are you getting 120 units where we started? Then here you have 2x plus 4y equal to 80. You can see that the constraints are fully utilized. There is no wastage or there is no slack. There is no lagging behind. Optimization is obtained. We have maximized the profit. 24 units of project A should be used. 8 units of project B should be used. This is for commercial complex. This is for residential building. So we have utilized the maximum units and also optimal units, and we have maximized the profit. That weekly profit for the company is around $10,400, and per month it will be around some 40. So per month if you calculate, so what you will get, we can do, you multiply it with 4. Yeah, this is what you get. So $41,600 per month is the profit. Thank you. Thanks for watching. If you have any doubts, you mention in the comment section. Thank you.